Hello everyone, I am Kushagra Vaid, and today we'll be studying Lorentz transformation. Okay, so Lorentz transformation is the key topic to study when you are trying to study general relativity. Additionally, this is to balance the dilemma that we were having of how the embankment of the light speed was out of control, and theorem for addition of velocities and the propagation of light in vacuum space was actually in a contradiction and in dilemma. So Lorentz transformation was there to help us solve this dilemma. Let us start with it. First of all, we have conclude two major hypotheses. That is, a time interval, that is simply the time between two events, is independent of the condition of motion of the body of reference. This means that any body that is moving, the time interval will of those if there are two specific different events happening, it will be independent of the condition of motion of the body of reference. This is the first hypothesis. The second we have is the space interval between 2 points, that is simply the distance. So the distance between any 2 points of a rigid body is independent of the condition of motion of the body of reference. So under both the conditions, motion did not really matter whether time was there or whether we were considering distance. Now, considering this very special thing, let's suppose we have velocity v for a person walking on the top of the colleges, and just below near it we have our embankment, that is velocity small w. To find the total of the velocities, we will have to add both of them. This dropping the two hypotheses I just told you about, do not consider them. But then we will have propagation of light in the vacuum space to be, for example, the same embankment over carriages and embankment below it. So if we consider V and W, then there would be a subtraction for it to get us the propagation of light. Again, a very, very major contradiction. Those two hypotheses weren't changing the game as well. So we need to have a set of mathematical equations that would either prove the systems and help us to stop and pose this dilemma. Because we all know that under classical mechanics, the speed of we all know what is the speed of light. The speed of light is approximately around 299,792 kilometer per second. So every middle schooler must also know about this. And this is same, but this condition was saying that over the embankment, the velocity was supposedly higher than below the embankment. This would clearly violate this. And to technically solve all of this, we had to develop the Lorentz transformation. Now let us talk about it. So I guess we all know about the coordinate system, the coordinate plane. If you are studying physics, you must know about the coordinate plane. The coordinate plane. Okay, so let's take three systems that are perpendicular to each other and were marked out and designated as coordinated planes on a coordinated rigid system. Those three systems would be X, Y, Z. With regard to the coordinate system K, then would be corresponding to the embankment. We were talking about the embankment previously. Now the system K would be in regard to that. So then the correspondence would be in regard of K, you would have K, in regard of K, you would have X, you would have Y, you would have Z, and we would have the regard of time as well. Whereas the system for K prime, the systems dramatically change, because then we have in this regard X prime, Y prime, and Z prime with regard to time prime. And we all know that X prime is definitely not equal to, or the prime numbers are definitely not equal to their equivalent of the same number. So we need to solve that. So in respect to three perpendiculars, we also had to regard to time with it. And then we will have to design a perfect coordinate plane for it. On a coordinate system, the coordinate system will be designated as follow, as I'm writing it. here and here. Okay, so and this straight line and this where z and this is z prime. This is k prime and this is k. Sorry, k and prime k. And then we have y prime. And then we have b and x prime. We all have regard to time over here, which is not especially mentioned, but we have the velocity regard as well. So look at the graph for that. Now, what are the values of k? K prime, y prime, z prime, and t prime with respect to k prime. And we're the same about the values that were not with a prime. X, y, z, and t and k. So what would evaluate? For it to derive, we would derive it by, let's evaluate. Now we will have to use the set of equations known as the Lorentz equations that will help us to get it out. So we would have x prime as x equals vt. Let me see, please. Sure. X over vt and 1 minus v square over c squared. And y prime would be y, z prime would be z. But the coordination problem really comes when we are talking about t prime, where t prime will be, according to I'm talking about the Lorentz transformation. Ahead of this, I'll just be discussing the Galilei transformation as well. So t is subtracted from v square over c square multiplied by x over root 1 minus v squared over c squared. This is the Lorentz transformation of our equations. And now to possibly considering all of this, just a second. So the final numbers that we will get for it will be x prime integral to x minus vt, and y prime would be y and z prime would be z as well, so there will be no change. And t prime would as well be t. This is the Lorentz transformation. But there is a specific part known as the Galilei transformation, which also actually helps us a more bit, and Lorentz also uses it for his transformation of these subjects, and we will be labeling at x would be x would be equivalent to ct. That will change the set of equations where x prime equals to c minus v t, okay, and root 1 minus v square over c square. Okay, and then we have for t prime, that would be 1 minus v over c t over root 1 minus v square over c square. And the final resultant we would get for x square after, simplifying this equation, that would specifically be ct prime. This Lorentz transformation was not only helpful, but really considering the change of how we had a dilemma with the previous equation sets that were regarding the complexity of how we were not able to agree on a standard limit of time and standard speed of time. Forgive me, standard speed of light. And embankments were creating a difference because we were using the addition of velocity theorems. That's all. So that we would have to, the addition of velocity theorem would create a contradiction to the speed of light. That would indeed be very, 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 very difficult, just simply a dilemma. So Lorentz transformation was really, really, really important to help us solve this dilemma. So thank you for watching. Kindly subscribe as well. Thank you so much.